So we're going to work another problem that involves the law of cosines, and it's a solve a triangle problem. Here it is, exercise 2, solve the triangle if a equals 4 feet, b equals 6, c equals 3 feet. So we need to find the angles here. Alpha, beta, gamma. So we know the three sides of the triangle, and we don't know anything about the angles yet. So my hypothetical picture might look something kind of like this. Let's see if I label A equals 4 feet, B equals 6 feet, C equals 3 feet. Then I got to get my angles lined up here. Across from A is alpha. Here would be beta. Across from C is the gamma angle. And I'm not going to write it out, but we should just pause to think about how law of sines isn't going to be very helpful here, because in each one of the fractions involved in the law of sines, we would, maybe I'll flip this up. Since we don't know alpha, we don't know beta, we don't know gamma, there's no way to get a law of sines equation with just one variable. So I'm going to move to law of cosines. We also talked in the last exercise about how whenever you're looking for angles, if you can use law of cosines, that's to be preferred, because when we apply the inverse cosine, there's only one possible angle that we get. We don't have that two-angle situation that we often encounter when we're trying to find an angle from the law of sines. So let's apply law of cosines here to find an angle, and I guess it doesn't matter which one I find first. Maybe we'll try to find alpha. And if I'm going to find alpha, I need the form of the law of cosines that involves alpha. That's the middle one on my card here. That starts with a squared. So I'll copy that down. I'm going to use the law of cosines. And I'm going to use the form that starts out a squared equals b squared plus c squared minus 2bc cosine alpha. And I'm going to plug in. So plug in a squared is 4 squared equals b squared is 6 squared plus c squared 3 squared minus 2 times 6 times 3 cosine alpha. That's 16 equals 36 plus 9 minus, I think that's 36, right? Cosine alpha. And just, again, don't make the careless mistake that is going to lead to disaster, where you take 36 plus 9 minus 36, because this subtraction cannot be performed before the multiplication between the 36 and the cosine A. So I can add the 36 and the 9 term in front, so that's 16 equals 45 minus 36 cosine alpha. But I cannot do the subtraction between the 45 and the 36. I actually have unlike terms there that cannot be combined. I first have to subtract 45 from both sides. And notice the minus sign stays. I still have negative 36 cosine alpha. 16 minus 45 is negative 29, I think. It's negative 36 cosine alpha. So I'll divide both sides by negative 36. And I get 29 over 36 equals cosine alpha. And at this point, I'm going to bring up my calculator to help me out in degree mode, because we're working with degree measure here. And 29 over 36, that's about 0.8056, rounded that off to 4 places, and take inverse cosine. And the inverse cosine of 0.8056 is 36.3 degrees. And that's my value for alpha. So alpha is equal to 36.3 degrees. I got one of my angles. Now, let's find beta. And we're going to use law of cosines again. I'm going to use the formula that has a beta in it. So it's the third equation. That starts out with b squared equals a squared plus c squared minus 2ac cosine beta. And I plug in again, and it's a very similar kind of calculation. 6 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 cosine beta. 36 equals 16 plus 9 minus 24 cosine beta. So 36 is equal to 25 minus 24 cosine beta. So the 25 has to get subtracted from both sides. 36 minus 25 is 11. And so I'm going to divide both sides by negative 24. And so here I have a negative number. I have this negative fraction, negative 11/24. As a decimal for that, I got negative 0.4583. Round it off again. And so now I'm ready to go ahead and calculate the inverse cosine of negative 0.4583. So you need the negative entry into your calculator. And what I get for this cosine is 117.3 degrees. So beta is 117.3 degrees. Again, that you only get one value from inverse cosine, and that's the one we want. Now we still need gamma, and I'm going to try to squeeze this onto the same sheet here. So use alpha plus beta plus gamma equals 180. You could use the law of cosines again, by the way, and some people use that as a way of checking their work, but I'm just going to plug it in here. So 36.3 plus 117.3 plus gamma is 180 degrees, because the three angles have to add up to 180. And for my gamma angle, I get 26.4 degrees. There are my three angles. Just back up a bit to get the whole, just about get the whole thing on here. And there's our second exercise with law of cosines. We just used law of cosines twice to get two of the angles. Then we figured out the third, since the three add up to 180. And that's what we needed here.